This is section 2.7. Use absolute value functions and transformations. Your I can statements. I can graph and write absolute value functions. So an absolute value function is a function that contains an absolute value expression. The equation looks like f of x is equal to the absolute value of x. On an absolute value function, when the x value is positive, the equation is just x. If the x value is negative, the equation is negative x. And where x is 0, our value is just x. The point where it starts, where it goes two different directions, is your vertex. That's either going to be the lowest point on your graph or the highest point on your graph. So just the absolute value of x on the right side will have a slope of 1. On the left side will have a slope of negative 1. Now we can take this graph and we can transform it. One way we can transform it is to do a translation. This is a transformation that shifts your graph horizontally or vertically, but does not change the size, shape, or orientation. A reflection is a transformation that flips a graph or a figure in a line. So the general form of the equation is going to be y is equal to x minus h plus k, where h and k is the vertex of your absolute value function. When you pull the h out of the absolute value sign, you will change the sign. So if it's x minus h plus k, our vertex will be at h and k. So if we graph the original function of y is equal to the absolute value of x, our center is at 0, 0, and it's going to have a slope on the left side of negative 1, and it will have a slope of positive 1 on the right. If we take a look at the equation, our vertex, instead of being at 0, 0, if we pull the positive 4 out of the absolute value sign, it's going to be at negative 4, and we have the negative 2. So our vertex will be at negative 4 and negative 2. So to graph the new function, we're going to go to the point of negative 4, negative 2, and we're going to put our vertex. Our slope is going to stay the same. So our slope on the left side will still be negative 1, and the slope on the right side will be a positive 1. Now, if we take our value and we are going to dilate it, we can either expand it vertically or compress it vertically by multiplying your absolute value by a value out front. As long as that a value is not 1, it is going to dilate your figure. If the value of a is greater than 1, it is going to expand your graph vertically. And if the value in front of your absolute value is between 0 and 1, it is going to compress your graph vertically. So if we have our original graph of y is equal to absolute value of x and we graph this, we need to graph and compare the graph of y is equal to 1/2 x. Because it is 1/2, this is between 0 and 1, so this means it's going to be compressed vertically by 1/2. For an absolute value, this means it's going to change the shape. So instead of going up 1 over 1, we're going to go up 1 and over 2. It's only going to go up half as high. So instead of going over 1, up 1, it's going to go over 1, up 1/2. If I go over 3, it's going to go up 1.5. At 4, we'll only be at 2 because we're only at half the value. This is changing the slope. So our slope is up 1 over 2 instead of up 1 over 1. So our new graph is the red graph. When we're comparing, we're just saying what's happening. So we are compressing the graph vertically by 1/2. Now, if we add a negative sign in front of your a value, that's not saying our a value is negative. That negative value is telling you we are reflecting the graph across the x-axis. So our original graph of y is equal to the absolute value of x is still going to start the exact same way. But now we are going to take our value, and instead of opening up, because this is a negative, it is going to open down. So we're going to reflect it across the x-axis. So this red graph is just by taking the value and reflecting it across the x. But we also have that 3. We have 3 times the absolute value. That 3 is telling us if we're going to compress it or expand it vertically. Because 3 is greater than 1, we are expanding the graph vertically. So if our graph is expanded vertically by 3, this means instead of having a slope of 1, it will have a slope of 3 over 1. Since it is now negative, this means we're going to go down 3 over 1, down 3 over 1. We're going to do the same thing on the left that we did on the right. So the final graph will be the blue graph. So that blue graph is the graph of the line y is equal to negative 3 times the absolute value of x. Now we can stretch it, reflect it, and translate it all on the same graph. So if we start, let's go ahead and move our center first. We're going to translate our graph. Remember, when you pull it out of the parentheses or the absolute value, you change the sign. So our vertex is going to be at 1, 3. This is because we translated 1 unit to the right and 3 units up. Because we have a negative sign in front of the 2, it means instead of opening up, it is going to open down because we are reflecting it across the x-axis. And because we have a 2 in front of the absolute value sign, it means we are expanding the graph vertically by 2. We know we are expanding it because the value is greater than 1. So if we go to graph this, instead of having a slope of 1, it's going to have a slope of 2. But we are going to open down, so it's going to go down 2 over 1, down 2 over 1. And the red graph will be the graph of our equation, y is equal to negative 2 times the absolute value of x minus 1 plus 3. Now it is possible to take all of these things and apply them to any function, so we can still stretch it or shrink it, expand and compress. We can still reflect it, and we can still translate on any function. So if we look at a function that goes to the points of 0, 0, 2, 3, and 5, 3, it says we want to take this graph and we want to stretch it so that its y is equal to 2 times f of x. This means f of x is your y value, so we're going to take 2 and multiply it by each of the y values. So at the x value of 0, we have the y value of 0. 0 times 0 is 0 times 2 is still 0. At the x value of 2, we have a y value of 3, so 3 times 2 gives us 6, so we're stretching this up to the 6. And for our x value of 5, we have a y value of 3. 3 times 2 is still 6. And you should end up with the red graph. This time we're going to start with the same starting point. So we're still at 0, 0, 2, 3, and 5, 3. The first thing we're going to do is, because we have that negative sign out front, we're going to go ahead and reflect this across the x-axis. So we're going to be at 0, 0. We're going to be at 2, negative 3, and 5, negative 3. So this is if we just take the function and we reflect it across the x-axis. But then we need to translate our function. Remember, when you pull it out of the parentheses, you change the sign. So this means I need to move every point 2 units to the left and 1 unit up. So if we start at this point right here, we move 2 units to the left and 1 unit up, we're going to end up here. 2 units to the left, 1 unit up. 2 units to the left, 1 unit up. And this will be our final graph.